Hello viewers, I am Kausalya. Today we are going to solve a problem related with an unbalanced load. So here the problem is, for the unbalanced circuit in figure, find the line currents. Second one, the total complex power absorbed by the load. So here you see this is the given circuit diagram, right? So again the source is of star network and the load is also of a star network. And IA, IB and IC are the line currents that flow through the circuit, and here we are going to solve this problem using loop method. Therefore the current flowing through this loop, right, this is a closed path, so this loop is considered as I1 and the current flowing through this loop is considered as I2, right? So now we are going to frame expressions by using Kirchhoff's voltage law. So here in this case, consider loop 1, right? Loop 1 includes these things, that is these two sources and one impedance and one resistance, right? So here when you consider mesh 1, you see here the thing is, okay, just look at this expression, right? So here this is your direction of current flow, right? So here plus to minus is taken as positive, right? And minus to plus is taken as negative, and again it is up to you. Okay, you can take any ways. So here just I have taken plus to minus as plus and minus to plus as minus, right? So here this voltage source, it is nothing but 120 with an angle of 120 degrees, right? And again here it is moving from minus to plus, therefore it is minus 120 with an angle of 0 degrees. And again when you look at this loop, you see here the current flowing through this J5 ohm is I1. So here it is plus J5 I1, and here again the current flowing through this 10 ohm resistor is, what about the current flowing through this 10 ohm? You see I1 also flows through this 10 ohm as well as I2 also flows through this 10 ohm. But the direction of current is reversed, right? I1 flows like this and I2 flows like this. They are opposite. Therefore, since we are considering our loop 1, here we have to write it as I1 minus I2 into 10, right? So which is equal to 0 here. So the next step is, here I had combined the I1 terms together, right? So when you combine I1 terms, here we will be having this 10 and this J5. Therefore 10 plus J5 into I1, and here it is minus 10 I2 equal to 0, right? So the next thing is, here the polar form is converted into rectangular form here. Similarly, this 120 with an angle 0 degree is converted into rectangular form. Now the remaining things we are writing as such. And the next thing is, here we are simplifying these two values, right? I am combining the real terms as well as this imaginary terms. So here this is our answer. And finally I am keeping I1, I2 terms on the left hand side, and I am moving this term to the right hand side. So you see here both the terms are with negative sign. When they move to the right hand side, they become plus here, right? Again when you convert this rectangular form to polar form, it appears like this. And finally I am simplifying. You see 29.99 can be written as 30 degrees, right? So this is your equation number 1, which is written for our loop 1, right? Now consider mesh 2, right? When you look at mesh 2, again what are all the elements present in mesh 2? You see this is your mesh 2, right? Again here we are having two voltage sources, one resistor and one capacitor, right? So while writing expression, as usual the same thing, here plus to minus is considered as minus and minus to plus is considered as a plus, right? So here in this case, so while writing expression, you see here we are having 120 with an angle 120 degree minus 120 with an angle of minus 120, right? Plus again when you look at this 10 ohm resistor, here both the currents flow through this, right? Both I1 and I2, and the current directions are opposite. So since we are considering loop 2, here we have to write it as 10 into I2 minus I1, right? So and finally you see 10 into I2 minus I1 and minus J10 I2, which is equal to 0, right? So now again the same steps, we are converting this polar form to rectangular form, and here we are combining I1 terms and I2 terms together, right? So again when you simplify this, finally this will be our expression, right? That is minus J. So here J contributes an angle of 90 degree as we all know. Therefore here we are writing it as minus 90 degrees, right? Here we are rewriting this expression, that is I1 first and I2 next, right? So minus 10 I1 plus 10 minus J10 I2, right? This is your equation number 2. So from equations 1 and 2, right? This is your equation 1 and this is your equation 2. We are writing these equations in matrix form. So this is your matrix form, right? So this polar form is again now converted into rectangular form here, right? So the thing is, now we are going to calculate the values of I1 and I2. So before that we have to find the value of del. So del is nothing but determinant of this matrix. So when you take determinant of this matrix, right, that is 10 plus J5 into 10 minus J10 minus of minus 10 into minus 10, right? So here you have to do multiplication, and plus 100 and minus 100 cancels each other. Finally we are getting 50 minus J50 in rectangular form, which in polar form is 70.71 with an angle of minus 45 degrees. Right, so this is your del. Now the next thing is del 1. So how to write expression for del 1? You have to replace this first column with this element, right? So when you rewrite, again here you have to find the value of del 1. So you have to multiply these two minus of these two terms, right? Again you have to simplify. You have to multiply, and again you have to combine the real and imaginary terms. So once you multiply, you are having terms like this, right? And once you combine real term, you see here 1800 and 1039.2. These two are the real terms. So when you combine here, we are getting 2839.2. And when you combine the imaginary terms, here we are getting this value, right? Again, this is in rectangular form. Now we are converting this rectangular form to polar form here. So this is your del 1. So now it is del 2. So here this is your del 2, right? The second column is replaced by the respective source values. So again we have to multiply. So 10 plus J5 into minus J 207.84 minus of minus 10 into 180 plus J 103.92, right? So just multiply. After multiplying and combining real and imaginary terms, right? You see here, this is 1039.2 and here minus into minus will become plus, right? So plus 1800. So when you add these two, that will give rise to 2839.2. And again, when you combine these two, you see here this is with minus sign. Here minus into minus will become plus, right? So here you have to subtract, and here the bigger number sign is minus. Therefore, minus J 1039.2. So this is converted into polar form like this. Now the next thing is we have to find I1 and I2, right? Once I1 and I2 are calculated, we can find the line currents here. So I1 is nothing but del 1 by del, right? Here you see minus 45. When it is moved upwards, it becomes plus 45. So minus 45 plus 45 becomes 0. Therefore the value of I1 is 56.78 amps. Now the next thing is I2. So here the value of I2 is given by del 2 by del. So again substitute the value. Here this is your answer, right? This minus 45, when it is moved upward, it becomes plus 45. So minus 20.1 plus 45 gives plus 24.9 degrees, right? So now what are all the line currents? Again when you look back at the diagram, IA, IB and IC are the line currents here. So again from this diagram you see IA is nothing but I1, right? Because I1 is the current that flows through this line. Therefore IA is equal to I1. So IA is equal to I1, which is equal to 56.78 amps, right? Now the next thing is we have to find the IB, right? So here IB, it is nothing but the difference between the currents, right? So here it is taken as I2 minus I1. So just substitute the values of I2 and I1 and this is your value of IB, right? Now tell me what about the value of IC here? IC is nothing but IC is equal to I2, right? Because I2 is the current that flows through this line here. Therefore, so this is your value of IC, right? IC is nothing but I2 and this is the respective value. Now we are going to find the power absorbed by the load. So here what are all the load values? So here we are having three types of loads, okay? Resistive load, inductive load and a capacitive load. Now we are going to find the power across each load, right? So now we are going to consider this reactance J5. The current flowing through this reactance is, it is I1, right? Therefore, power absorbed by inductor J5, it is given as, because the current flowing through this J5 reactance is IA, right? So power is given by I square R. So here it is IA square. Here we are using the term Z, right? So Z represents the complex impedance. So since here we are having different types of impedances, we are denoting it as Z. So what is the value of IA square? You see IA is nothing but 56.78. So 56.78 whole square multiplied by J5. So here the answer is J16120 volt ampere, right? Now, so the next thing is power absorbed by the 10 ohm resistance. So here the current flowing through this 10 ohm resistor, it is nothing but IB, right? We have already calculated IB. You see, the value of IB is 25.46. So 25.46 whole square multiplied by 10. So that gives 6480 volt ampere, right? Since everything is a complex power, we are denoting it as VA. Now the next thing is power absorbed by minus J10 ohm load, that is a capacitive load. So the current flowing through that capacitive load is, again you look back at the diagram, so it is minus J10, right? And the current flowing through this is, what is the current that flows through this part? It is I2, right? So here you see I2 is 42.75. Therefore, here it is 42.75 whole square multiplied by minus J10. Therefore, here the answer is minus J18276. So the total power absorbed by the load is, here we are going to sum all the values of power. So power absorbed by the inductor and resistor and the capacitor, and finally this is your answer, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.